Welcome to The Explainer. Today, we're diving into the vast, dark spaces between the stars. We're going to uncover a hidden architecture of our galaxy, a silent population of worlds that, until now, we've barely been able to see. You know, when you think about our galaxy, you probably picture stars, right? And the planets that orbit them. But what if that's only half the story? What if the galaxy is actually teeming with trillions of free-floating, starless worlds, a vast, invisible population that we're only just starting to detect? Yeah, you heard that right. 20 to 1. That's the staggering ratio some of the latest models are predicting. For every single star you see in the night sky, there could be 20 wandering rogue planets out there in the darkness. We're not just talking about a few more planets here. We're talking about potentially trillions of these objects in the Milky Way alone. That completely changes our picture of what our galaxy is actually made of. Okay, but wait a second. If these worlds don't have a parent star to light them up, how on earth do we find them? I mean, for all intents and purposes, they're invisible. They're cosmic ghosts. Well, the answer comes from this beautifully clever trick of physics that Einstein himself predicted. It's called gravitational microlensing, and it lets us see the unseeable by watching how an object's gravity literally bends the light from a star far, far behind it. So here's how it works. You have an invisible planet drifting through space. It just happens to pass directly in front of a distant star from our point of view. Its gravity acts like a cosmic magnifying glass, and for a brief moment, it makes that star's light flare up. For astronomers back here on Earth, that little flicker, that spike in brightness, is the telltale signature of a ghost planet passing by. And this isn't just a theory, it has become an incredibly powerful tool. By looking at a single lensing event from two different places, Earth and the Gaia Space Telescope, scientists were actually able to triangulate the planet's position. And because they could do that, for the very first time, they got a precise measurement of its mass. They literally weighed a Saturn-sized ghost. So finding these worlds is one thing, but that just opens up a whole new can of worms. What's their backstory? Where did all of these wandering planets come from? Essentially, there are two competing origin stories. You have the exile theory, which says they were born in a normal solar system but got violently kicked out. And then you have the orphaned theory, which suggests they formed all by themselves, collapsing from a lonely cloud of gas and dust far from any star. Right now, the exile theory is probably the leading contender. It paints this picture of really chaotic young solar systems, where giant planets are migrating all over the place. It's like a game of cosmic billiards, and these smaller worlds are the ones that get smacked right out of the system and sent flying into interstellar space forever. But some objects just don't seem to fit that story. Take this one, CHA 1107-2676. It's a huge rogue planet, maybe 5 to 10 times the mass of Jupiter, and it's about 620 light-years away. It really challenges that simple exile narrative. And get this, astronomers recently caught it in the middle of a massive growth spurt. It's pulling in material from its own little disk at an incredible rate. This is some of the strongest evidence we have for the orphan theory, that yes, some planets can actually form just like stars do, all on their own out there in the dark. You know, we don't always have to peer across light years to find these clues. Sometimes the evidence comes to us, paying a visit right here in our own solar system. Pretty recently, we spotted 3I/Atlas. It's only the third confirmed interstellar object to pass through our neighborhood. At first glance, it looked like a comet. It had the bright coma and tail, but its behavior was, let's just say, it was unusual. And when I say unusual, I mean statistically really improbable. Its orbit, its timing, even the direction it came from, they all lined up with other astronomical points of interest with incredibly low odds. On top of all that, it was accelerating in ways that gravity alone couldn't explain, and its chemical makeup was a total outlier compared to any comet from our own solar system. Now, the mainstream scientific view is, look, we should expect weird things from other star systems. Comets can be strange, and this is probably just a natural, if very peculiar example of that variety. Still, for some researchers, the sheer number of these low-probability coincidences all stacked on top of each other in a single object is just too much to ignore. It really makes you ask the question, could all these weird things, taken together, be pointing to a completely different explanation? It's a fierce debate, and it really highlights just how much we still have to learn. So this all leads to the ultimate question. How do we solve these mysteries for good? How do we go from finding just a handful of these things to actually mapping the entire hidden population? Well, the answer lies with two groundbreaking new observatories that are about to come online. You can think of the Rubin Observatory as our new lookout, watching for visitors, while the Roman Space Telescope will be like our new galactic census taker, counting up all those invisible worlds. Just think about that for a second. To date, we've only ever confirmed 3 interstellar visitors in all of history. The Rubin Observatory is projected to find up to 70 per year. It's going to turn a once-in-a-decade discovery into a regular event. And what's even more exciting, maybe, is the Roman telescope. It's designed specifically for these microlensing surveys, and it's so sensitive it's expected to find hundreds of rogue planets, even ones as small as Earth. For the very first time, we're not going to be guessing at the numbers. We'll actually be counting them. So, we are standing on the brink of a revolution. The silent, supposedly empty spaces on our map of the galaxy, they're about to be filled in. And as we start to reveal this hidden architecture, it leaves us with one final, incredible thought. What else have we been missing in the silence?